It's early 1970, and the Apollo manned missions to the moon are in full swing. Much to NASA and scientists' surprise, they found a new type of feature on the moon that to this day aren't fully explained. As the astronauts looked out their viewports while in orbit, they saw strange enigmatic patterns. Silver swirls tattooed onto the lunar surface. And to make things even stranger, all of these patterns had anomalous magnetic fields and signatures, which is quite the conundrum, because the moon, you see, has no magnetic fields. On top of this, these mysterious markings also showed no signs of aging, as if they were perfectly preserved for billions of years, fully unweathered. Join me as I take you on a tour of the celestial safari, diving deep into what these things look like and what scientists' best guesses are as to what their origins may be. How you doing? My name is David Hoyt. I do scientific outreach at an observatory. You're watching Celestial Safaris, where daily I take you on trips around the universe, showing the more exotic and interesting things that are out there. Today we are doing a companion follow-up video to a prior video I did, which was called Top 5 Most Mysterious Things on the Moon That Scientists Aren't Really Sure About. This is number 4, which is magnetic anomalies. As I mentioned in the intro, there are some very strange, enigmatic, swirling, silvery markings on the moon that took NASA and scientists quite by surprise when they first discovered them back in the Apollo missions in the early 1970s. To this day, nobody's quite sure what they really are. However, there's a lot of pretty good explanations, and we're going to dive deep into it. And at the end of this video, you'll probably have a very good understanding of what these things most likely are, and they're pretty cool. They're actually really, really cool. So let's get into it. So although these were first discovered by NASA during the Apollo missions and astronauts as they were orbiting the moon, it turns out that astronomers have actually seen at least one of these mysterious magnetic anomalies this whole time, at least going back into roughly the 1600s. In the bottom southwest corner of the moon, in one of the most prominent oceans there is, you will see just right on the edge of the moon a small little tadpole-shaped, very bright white silvery object. Back in the day, people thought that was probably a crater than a mountain. They had no idea because they couldn't have telescopes that could look closely enough at it. And it wasn't until we actually were able to send probes to orbit the moon that we got good close-up shots of this thing. This thing is called Rainier Gamma, and it's near the Gamma plateau and formations of lunar features. And it looks like kind of like a giant tadpole. Some refer to it as the octopus, and if you look at it, you can kind of see both. And it turns out it actually is not a crater or mountainous or anything like that. It's not a volcano. It is actually almost perfectly flat. Not quite so, and we'll get into that in a little bit. But so it turns out people have actually seen one of these things in the past and just had no idea. And then once they had the Apollo missions going to the moon, they discovered a whole lot more of them. And it didn't really matter if these objects were down in the lowlands and the basalt flats, which we call the seas, or if they were up in the highlands, kind of like dotting the sides of mountains. They were literally found all over the place. So NASA, when they were orbiting the moon, went on to discover several of these enigmatic kind of silvery swirls. Predominantly, though, in 3 or 4 major locations. The first one is Rainier Gamma, which you've seen photos of just now. The other ones were over in Mare in Gelli, and the other one in Mare Marginis, and another one called the Furzov swirls. And so they've discovered that not only were these mysterious swirls and markings having strange magnetic anomalies underneath them, which in itself is quite kind of shocking and a conundrum considering the moon has no magnetic field, they discovered that the regolith, or the soil directly underneath these swirls, got their silvery bright pattern because they looked completely unweathered. And it turned out that when they were doing spectroscopy and analyzing sort of like the soil there from space using probes, it turned out that indeed a lot of that soil was unweathered, as if something was protecting it from solar radiation. See, solar radiation kind of gives moon dust like a suntan or a sunburn even. It weathers it. And that's where you kind of get some of the darker patterns that you see around these bright silvery swirls. That's the weathering that you'd normally expect on the moon from the sun and the sunlight hitting it. And these weren't getting any of it. It was almost as if they were untouched by solar radiation for billions of years. So they wanted to try and find explanations as to why you would have anomalous magnetic fields on the moon, creating these strange patterns. And they kind of came up with 3 different ideas. The first one that never really took hold, but it was the first idea that presented, was comet impacts. Maybe a comet smashed into the moon, and if you look at a Rainier Gamma, it kind of looks like a comet could have hit there. Maybe the comet ejected a magnetic material that somehow got buried just lightly underneath the lunar surface. Not the most popular idea. The second idea was that whatever was causing these magnetic fields, which was up for debate and still is, these magnetic fields were acting kind of like a force field, protecting the soil underneath it from solar radiation, deflecting solar rays, kind of like a shield in Star Trek or Star Wars. So the soil underneath it basically had a sunscreen. It was never getting any direct solar radiation to weather it like the soil next to it, and that's why it stayed brand new and shiny looking. The third option is that whatever this magnetic field is was actually acting like a giant iron magnet that pulls iron fillings to it, but in this case, specific types of lunar soil. Lunar soil is broken down, or lunar dust, into 2 major categories. One that's high in iron, and another one called feldspeth dust, which is high in aluminum. And aluminum is a lot more electrically conductive. Now, we know, if you've watched my prior videos talking about strange lights on the moon, that solar radiation that's bombarding the moon all the time, because the moon has no magnetic field, electrostatically charges this metallic dust, particularly the aluminum, which then floats up in the air, gets aloft, and it gets around the moon pretty well. It can migrate all over the place. So they're thinking that these magnetic fields, these mysterious magnetic fields, are selectively attracting this aluminum type of dust, which then gets secreted or deposited along the field line, creating these interesting silvery swirling patterns. So as a whole, option 2 and option 3 are great, but there is some problems with option 2 and some problems with option 3. And it turns out if you hybrid the 2 together, they actually meld really, really well. So the latest theory is that, yes, these mysterious magnetic fields are indeed acting like force fields, deflecting solar radiation, and they kind of know this is indeed what's happening because when they do a spectroscopy of the soil there, they can tell that there is less solar hydrogen being deposited in that soil. So we know that the solar hydrogen that would be coming in on this solar radiation is actually indeed being deflected and is not being imbued into that soil like it does all the surrounding soil or anywhere else on the moon. So we do have confirmation that whatever it is acting like a force field. However, just because you got suntan on doesn't mean you're not going to get a sunburn eventually. And this area directly underneath these lunar swirls should weather over time. At least if they're billions of years old, they should weather. And the weathering pattern should be every so million years or so. Eventually it'll succumb and end up looking weathered. And that's not happening. So they think what's going on in conjunction with that is that this high in aluminum type of dust is getting deposited over there, and so like fresh snowfall, every so often when these dust storms come through and get attracted and pulled to these swirls on the moon, they kind of replenish the surface and kind of give it a nice brand new shiny coating. So it kind of renews the process. So the latest models that scientists have been using to study these strange magnetic fields on the moon and these weird patterns is that the iron, because I said there was 2 types of dust, the heavier dust, which is iron, and then the lighter, more electrically conductive dust that is more prone to movement and attracting to magnetic fields, which is the aluminum dust, do indeed get separated by these magnetic fields. The iron gets dumped on the outside, and that's kind of why it's a little bit darker. And then on the inside, the aluminum gets separated. And furthermore, they are doing topography scans, and they're discovering that although these things at first glance appear to be very, very flat, almost all these magnetic swirls, these strange lines, have indentations. They are kind of engraved into the surface. On average, they're about 9 to 13, 14 feet deeper than the surrounding soil. So not only are they attracting this type of dust, they work like perfect little sand traps, like on a golf course, to trap this dust. And so that begs the question. We don't really know where these magnetic fields are coming from. We've got a pretty good understanding of why it's acting like a deflector shield, deflecting solar radiation, preserving the soil underneath it. And we've got a good idea of how that feldspath aluminum dust actually ends up there in the first place because, again, of these magnetic fields that are anomalous. Now, it turns out these indentations underneath these patterns give us a little bit of a clue, and that's kind of what scientists are following up on. Back in the day, there's some volcanism and lava flows and stuff on the moon, and they think that these lines are actually forming directly above sublunarian magma or lava tubes, or even like lava shelves. And when that lava finally cooled and those tubes collapsed, so did the ground above it, which is why they kind of create those nice little dust traps. And under certain conditions, it doesn't happen that often on Earth, but it can totally happen on the moon. When that lava cools rapidly, it can become highly magnetic. So that could be why you've got these magnetic fields. That raises another question: where do these lava flows come from? Interestingly enough, it comes from the other side of the moon. It turns out that most of these swirling patterns have features on the direct opposite side of the moon that correspond with them, or at least they think they do. For instance, Marangini and Mare Marginis both have features on their antipodes. So if you've got the moon here, an antipode would be something on the direct opposite of that. So if you've got England, the direct antipode for that would be Australia, for instance. Similarly, on the moon, you've got Marangini. Its antipode is the Imbrium Sea, directly across from it, which is a massive impact basin where a huge meteor slammed into, or asteroid slammed into the moon. So, and similarly enough, Mare Marginis also has something on its antipode opposite of it, which is the Oriental Sea, which is, again, another major impact basin. So what happens when you've got major impact basins? Like a shockwave, when a bullet strikes something, you've got a shockwave that will travel through the moon. So you've got this asteroid slamming into the moon on one side. A shockwave will travel through it and create convection and heat, and that will actually start forming lava on the opposite side. And these swirling patterns you can almost think of as like the exit wound. That's where that lava is coming boiling up towards the surface suddenly from the shockwave of whatever struck on the opposite side of the moon. Interestingly enough, if you look at the moon, the near side of the moon and the far side of the moon look drastically different. The near side of the moon is familiar to us. We've got all those dark gray seas of basalt, which is lava flow. And the far side of the moon, some people call it the dark side of the moon, is just covered in craters. There's almost none of those lava flows. There's like one, and that's about it. It's covered in craters. Interestingly enough, the very bottom near the South Pole on the far side is the largest impact crater in the entire solar system, called the South Pole Aitken Impact Basin. And you have a asteroid that has left a chunk of metal about 5 times bigger than the state of Hawaii underneath it, about 100 miles under the soil there. That created such a massive shockwave traveling through the moon that, again, convection and heat built up, and that's where all this basalt and lava and volcanoes appeared on the side of the moon that we see. That's why it's so drastically different and why it has all these lava flows. Again, you can think of it like an exit wound from like being shot with a bullet or something like that. Only in this case, for the South Pole Impact Basin, that bullet is still lodged deeply in there. So they do know that all these magnetic swirls have corresponding, or most of them do, features on the opposite side of the moon, and they're probably related to ancient asteroid impacts billions of years ago, and the corresponding shock waves traveling through the moon and then creating these wounds on the far side of the moon, or our side of the moon. And then when that lava cooled, it created strong magnetic fields, which then acted like force fields, protecting the soil underneath it, and like magnets, attracting aluminum feldspar dust to them, preserving them over time and kind of giving a new coat. So that's the basic breakdown as to what scientists think these mysterious swirls are. They're absolutely beautiful. They're one of my favorite features on the moon. Personally, I think Marangini is probably the coolest looking one. It's got these weird wavy kind of patterns to them. Of course, the tadpole, as I call it, Rainier Gamma, is also pretty neat, and you can actually see that through your own telescope next time there's a full moon. Go look in the southwest corner, and you'll see a bright silvery tadpole-looking thing. It's pretty small because it's not that huge, but you can see it. Maybe with a good pair of binoculars, and know that you're looking at a magnetic anomaly on the moon, and it's not fully explained still. Now, NASA is actually sending out a mission this year, 2024, I believe, part of the PRISM program. And underneath PRISM is going to be something called the lunar vertex. And lunar vertex is actually going to be a rover, and it's going to be landing at Rainier Gamma, and it will be cruising right across it, taking all sorts of samples and doing all sorts of experiments to try and finally get to the bottom of what these things are. Are scientists right? Is their working theory actually correct? We will know later this year, and I will do an update video at that time. So again, thank you for sitting through this and listening to me explain to you what these magnetic swirls are, these magnetic anomalies, how they most likely have formed, and some of the cool things that they do. I mean, who knew the moon has some little force fields up there protecting its surface in some places. If you enjoy this kind of stuff, I am putting up all sorts of videos. I'm moving on from the moon soon to a lot of the more exotic moons in the outer solar system. I'll be focusing on Io, Enceladus, Titan, and Europa. Those will be my next few videos. So if you're interested in that stuff, stay tuned. Hit the like button, subscribe. It helped me out a lot. Do the thing. And I will talk to you guys very soon. Thank you. This video is dedicated to Belinda. I spent countless hours sitting next to you on a couch in a small no-name town in rural Queensland, Australia, where you gently encouraged and guided me into reconnecting with my passion for education. If it weren't for you, I would have never had the courage to start writing those blogs and science articles back then. And I just wanted to say thank you. I would not be having the job I have now, or making these videos on YouTube if it weren't for those precious moments spent together where you helped me reconnect with a long-lost passion of mine. So thank you. I hope you're doing well wherever you are, and hopefully you'll see this video.